Orange and black, Halloween colors, even though it's not even close to Halloween. It's really hot outside, summer. But orange and black, orange and black, orange and black. Okay. Problem number 8, the last problem for this little subunit on our acids bases for the week. This one, I decided to throw this in because I was doing all acids. Excuse me, a little hiccup. All acid stuff, and I wasn't doing any bases. So I'm going to give a base its due. I'm going to give a base its due. And this one says calculate the KB. We have to calculate the KB of the base. So we don't know the base, so we're going to have to calculate it. All right, so it doesn't tell me what the base is. I just know that I have 0.3 molar of it in this week. Okay, so it doesn't really matter what it is. If I know that I have a particular concentration of it to start with, initial ice chart, then I can go ahead and do the problem. But let's write it down. I would write it like this: base. Okay, we don't know what it is, but it doesn't matter. It'll be fine. Trust me. Trust me. It's weak, so I got to put arrows both directions, and then it becomes base positive plus hydroxide negative. We're going to have hydroxide floating around somewhere. It's a base, and that's what it does. You put a base in solution, you end up with extra hydroxide floating around. Now, it could be like lead hydroxide, you got hydroxide floating around. Or it could be ammonia, and the ammonia chews up, that's my chewing sound, chews up some of the hydrogen, leaving you with extra OH. Doesn't matter what it is, that is a generic way of writing a weak base reaction. All right, so let's write a nice chart. The initial concentration was given as 0.3. Okay, I would initially start out with none of this and none of this. Over time, my base will make some of this, so I'll lose it. Gain some of this. Gain some of this. And equilibrium 0.3 minus x, x, and x. Now, I haven't even bothered looking. Oh, I remember. I was going to say I didn't bother looking, but I did. We're going to find the k value. All right, well, how am I going to find k value? I remember? K expressions are equal to your products over your reactants, right? I'm not given that. This time I'm figuring this out. In the last two problems, you were given this, and we solved for something else here. I need to figure that out. So let's go ahead and put our products, x squared, over the reactants, 0.3 minus x. All right, this is a weak base. And 0.3, I don't have the k value to divide by. And 0.3 is a pretty good concentration, and so a weak base is probably small. I want to make an assumption here that I can get rid of that. And actually, you can make that assumption because I've told you that we're only going to do one quadratic when I can't get rid of it, and it's not this problem, okay? It's not this problem. So we are going to get rid of this bad Larry right here because I know it's going to be very small. And when we do the calculation for this, it comes out to be a very small k value. And if we do the world under, don't need it. Don't need it. Okay. All right. Wait a minute. Wait, I can't do this. I have a k. I don't know what that is, and I don't know what that is. I can't do this problem. That's it, man. Game over. Okay, good. Good problem. All right, we're all done with this problem. Can't do it. No. Look. We were given a hint here. We were told that the pH of the solution is 10.66, which makes sense. The base, so it should be in the alkaline range, 10.66. So I know the pH is 10.66. Well, how does that help me? We want to figure this out, right? Yeah, okay, that's what it says. So we need to know that, right? Yeah, we don't know it, right? I know, right? But X is going to be the concentration of the hydroxide. Ooh. Now, we were given the pH of the solution. If I can use the pOH equation, solve for OH, boom. Got it, figure it out. Okay. Let me repeat what I just said. Let me go, what? All right, pH is 10.66. If you take 14 and subtract pH or POH, you get the other one. So if we take 14 minus 10.66, that's going to give me 3.34. What is that? That's my POH. So the POH is 3.34. So what? That doesn't help me, because that's not X. No, it's not. However, in our POH equation, which is equal to negative log of OH, the OH is the X. Boom. Let's solve for it. I know what the POH is. We just did that. We took the 14 and subtracted the pH. So that's 3.34. So 3.34 equals negative log, distribute the negative, so negative 3.34 equals the log of X. Anti-log that. I keep saying anti-log. I'll say inverse log. You might have learned it is inverse log, not anti-log. I'm antiquating myself. I'm so funny. Oh, I just shut my computer. Stop it. Okay. So, second function, log, negative 3.34, enter. Boom. All right, we get 4.57. 4.57 times 10 to the negative fourth. So that means X, which is equal to OH, which is equal to that right here, is 4.57 times 10 to the negative 4. Oh, we are so close to being done. Now that you know what the OH is, which is the X, put it here, and then solve for K. So 4.75 times 10 to the negative 4 squared divided by 0.3. All right. Times second function answer. Enter divided by 0.3. We get 6.96, or around 7, times 10 to the negative 7th. And what do we get for an answer on the sheet? 7 times 10 to the negative 7th. Nice! So K, 7 times 10 to the negative 7. If you go back and check the rule of 100, that divided by that is really, it's like 10,000 or something. So yeah, we got rid of that X. All right, that's the K value. And that's what it would be for this week base. And that's what it would be for the last problem for this week. All right, Lab Partner, you did an awesome job today. I appreciate you sticking around for this video, and we will see you soon.